thank you. Yes, so I looked through the instructions again before I came here, and it says we should not compare technologies, and well, I'm going to do that, but that's fine, because they're all good, right? Python and friends. And indeed, half of the talk is why I think Guix is great, especially for Python, and what basically what Guix is from a perspective of Python problems. And the second half is like how all the difficulties that Guix brings to for Python. That's it, because does any of you have used Guix? Well, yes, one person, and Nix or NixOS. That's more, that's what I expected. I thought I should at least try NixOS once before I come here, because there will be some people here that tried it. But I didn't, actually. But that's fine, because we can do everything. I think the more choice, the better, actually. Yeah, so I was like, for me, this is obvious to have Guix and Python together, because this is, but I was like, how can I wanted to convey that to you, why I think so. So what is Guix? I also have, so I have some screenshots of code, but I was like, I can just show the code directly itself. So Guix both an operating system and a package manager and an environment manager. And basically the arrows are basically what I will focus on here. It started as a package manager, forked from Nix, and then, well, it became a whole operating system. And actually, some 3 years ago, I was like, oh, I'm just going to install this because it like, sounds cool. And then well, it just worked. So I was like, okay, great. Because, yeah, usually these experiments, you try a new operating system and you discard it after 2 weeks of frustration. And this stayed for 3 years. What I like about it is that very declarative. You just, I will show you my config. That this is part of my config. And that makes it very reproducible, and it's all in scheme, what I also like. And I think that's, I don't know, maybe the main difference with Nix. But I was like, you have all these declarative systems, and but they're all in YAML, and then they're all different kind of YAML. And at some point you get like Turing complete YAML, and it was like, if you start having if statements in your YAML files, then you're doing something wrong. Then you can just better start with a real language. I mean, you could also use Python, but these people use scheme. And well, another little bit of history are that there's actually in the Guile, so it's not actually scheme, it's Guile, which is a scheme. Well, scheme is the language and Guile is then the interpreter. So within the Guile manual is a nice discussion about in the 90s that people were looking, that GNU, but also other groups are looking for a scripting language to extend the C code. And there were 3 contenders. That was TCL, Python, and Scheme. And for example, my employer at the European Southern Observatory, they decided to choose TCL as their scripting language. What that was perhaps the worst choice of the 3. But that was the most stable at the time. Python was discarded as being too new because it was in the 90s, and Scheme was not, there was no, at least for the GNU people find there is no good scheme. The existing scheme interpreters were not good enough, and then at some point they invented their own, and that they decided to be is good enough. I can judge that. But I found this history interesting, that Python was already also, like Python could have been the scripting language for the entire GNU system, but that didn't happen. Or Emacs, the Emacs Lisp could also have, but Emacs Lisp is a bit clunky in some ways, so they didn't want that either. But what I like is the declarative nature. So basically this is my config SCM for this machine that I'm looking at. And I can just define like everything in a sort of declarative way, like here are some kernel arguments I added. So this is a bit of a messy file. And it started as one small file and it became larger and larger, and at some point I was like, oh, this is actually a programming language, so I must be able to abstract this away. So now it's actually separate files that I then imported at the top somewhere. It must say something like, well, this is all things I don't, existing packages, but here are my own things that I added. So, and that is really what I really like. You can just arbitrarily add things to this. I mean, you can also say like, if it's Wednesday, then do this, but that will reduce the reproducibility. And then I also decided to add some the herd kernel to this, because I could just do this in a virtual machine. That's all sort of easy suddenly, and that's what I like about it. And especially with Python, because so these are the 3 Python problems I want to solve with Guix. Basically the packaging, the environment management, and the reproducibility. And actually, so I just put this talk by reference to this talk by Daniel from 2013, because that was actually, that really helped me put on this path. That was the first Pygrunn and Friends conference. Really is this long ago? Whatever, because then it was like, oh, we can also put Haskell in this conference. And I was like, oh, this is interesting. Scheme as well. Yeah. And I will explain these problems, but you know them, but still. So the packaging, so I realized at some point, oh, I'm maybe on the older side of the people by now. It's fine, because this is how you install the Python package. In the past, it was just like, there was no packaging at all. You just had this some websites on, I thought I opened it. Well, let's open it again. Why doesn't it open? I just tried this. Whatever. But there was just random website where you downloaded packages from, and then you those you just copy and paste it. This is interesting. Now the battery should be fine, but because I replaced it, but it went bad at night. So so this alarm is at 90% because it used to be at 90, 80, 0, and now that's not the case anymore. But it kept the alarm because I bought this. Yeah, so the Guix people are very much more fundamental in their free software stuff. So than the Nix people. I mean, you can install anything you want, or any kernel you want. But now I have an entirely Libre kernel as well. So I got this laptop, so it would hopefully be totally Libre possible, but it was not. So I also have a USB dongle for my Wi-Fi card. But this was just an experiment. I know, but that does mean I could easily replace parts. But then we got like PyPy at some point, it was great. But if you're in the scientific community and you want to install NumPy and SciPy, that was just a pain. It's easy now, but then it was a pain because you have to compile CBLAS and whatever, and Atlas or whatever these libraries are called. And it's just, especially if you're a bachelor student, you have no clue what you're doing, so this just fails. And actually, though one thing, it was Patrick and Taker, so one thing we did, we had a sort of a shadow IT. We had basically, we used Stow. Does anybody know Stow, this new program? It's one person. So we basically compiled everything with a prefix somewhere random, and then you used Stow to make symlinks, and then you could basically, well, get everything working through symlinks. And it was like, I don't know, this must be a better way to do this. But then we got, Conda solved many of these problems and introduced many more. And then we had here a keynote talk also in 2013, was the best year, I think, of Pygrunn, about that Python, the motto is do everything. There should be one way to do anything, and there should be preferably one obvious way and preferably one way, whatever. Except for packaging, there are 10 different ways, so we had more. And now we have pure poetry and UV, and now I just added Guix. Well, Guix is not, these are all Python things. Guix is, of course, not specifically. Because how actually installing a Python project, how I install a Python project is like I start with some Podman from installing some packages, actually basically the base operating system. Then either DNF or up to add some more libraries, and then sometimes in a scientific environment you can use module, well then you use either of those, but whatever. And then you install packages with Conda, and then with pip, and then I also have some NPM dependencies or whatever, and then actually I still have to copy some manual things. I was like, yeah, but the two problems I have for this is that one is these are all per language, sort of. You have like, why do different languages have different things? And the other one is that why does for your user space dependencies and your operating system dependencies you use two different things? And like, why should they use two different things? You should use one thing. And you can actually make your own RPM packages, of course, but I don't think anybody does that. I think, so that's just, I found that I should do something better. Oh, and I put the obligatory XKCD because adding a new thing to this just, well, doesn't actually remove any of the others, and any of the others are just as good as well, right? I mean, they all have their place for various things. Oh, yeah, I should show a Guix package, of course. That I wanted to show it earlier. Because we were talking about packaging. So I was looking for what is the most, I thought I must show a popular package. So, and I was happy with your talk this morning because I was like, actually, I looked up what the most popular package is, and it was actually Boto3, and I was like, I don't know, I've never heard of Boto3 before except for just now. Well, I have heard of it before because I fixed some Boto3 packages on Guix, but I didn't know what it was then. I thought Python requests should still be pretty popular, and it is. It's like number 6 on the list of popular Python packages. Yeah, I thought I should show code. Yeah, just show this. So this is basically, in my free time, I write these kind of things. So basically, you just define the name of the package, the version, the source origin. So you can basically reuse just PyPy. So it's just not replacing PyPy, it just uses this. But now the tendency is to use more directly the Git source because of this supply chain attack stuff. You don't know what is actually in this PyPy package, of course. And then it also just reuses the Py project builds. It's basically it just runs whatever is in Py project Tomo. And this is I like this example actually because of course so Guix tries to make everything reproducible so you cannot test with internet access. Like your package should work without internet. So many Python packages actually have like in this their test flags like do not do all these tests because they require the internet. And sometimes that's like 90% of all the tests in the package. But yeah. And inputs to the package. Well, this is basically any package manager does these things. So, and I was hoping like if Guix if something will replace Guix, I can just write something that converts this to whatever the new thing is. And then I was like, Daniel, can you help? So I was thinking about translating some scheme things to Python, and you notice you have a conception in your head, like what is this? So this package has these attributes, and it's a record and scheme, and then I was like, what is this in Python? Is it it's not a named tuple, but it's also not an object because there's no class. It's sort of, I don't know. Doesn't really matter, but it's interesting. That helps to learn a language that changes the way you think a bit, instead of, yeah, it's interesting. And the second thing is environments, because we have all the, yeah. So also a bit of a history about Python environments. In the beginning, you could just test Python path, whatever, and then we got virtual env. It was very wrong, and because we had virtual env wrapper to actually make virtual env useful to wrap our Python programs. And then we got conda and PyVenv, and I was like, I didn't really remember the history about this because apparently they were both added at the same time to Python, and then one was PyVenv was removed, and now we have poetry and UV, and but I was like, these are still Pythons. Why do you need a language-specific environment manager? That doesn't, to me, that didn't compute. Like, I don't know, it's just more or less by accident that it's a Python project. And how I do this actually in reality, you have the hardware, which is changing all the time, and on that I run a VM, and on that I run a Podman container, and in that I install conda, and I still need to set Python paths for some packages that are not properly packaged. So I still need, I was like, yeah, there are 5 different things to do. Why? I don't. So I added the 6th one to do, so that makes it worse. Oh yeah. So basically, the environments in Guix. So first, let me show the store in Guix, because the basic is that you don't actually. Now I notice a difficulty with my setup because I cannot switch tabs and hold the microphone. I just wanted to show this. So this the store is. So you don't actually install things. You just put these packets in the store, and then they are there on your hard drive, but you don't use them. Basically, they're all isolated in a way, and then all these environments are essentially a directory with symlinks to the store. Yeah, so you don't then install them. And the nice thing is this is a sort of the syntax is not. I mean, you use the same thing for all these things. So an environment, Guix shell just opens an environment that's still polluted with your host environment. But you can have a shell -- pure, and then you actually remove some environment variables from the host. But you can also do -c, then you actually start a container, like a Podman container or something. And you can do system VM, then you can create a virtual machine, and you can also create your entire system. Basically, these are the same, mostly the same. Of course, when you configure your own system, your hardware, you need to have UIDs of your hard drives in there somewhere. And of course, you don't need those in a container. But conceptually, there's not so much difference from that. And I think this is sort of liberating. I feel more in control. I mean, all these other tools are nice as well, but still, I like this. Yeah, and it was really with Python that made this. I got frustrated with how this is done in Python. And I was like, I need something better. And reproducibility, because if you have perfect reproducibility is easy in theory. You have a perfect container file, you have a set of log files, either in conda or poetry or whatever, or UV, and then you have perfect availability of binaries. But like just a couple of weeks ago, I got a bug report that our software didn't work on CentOS 7. I was like, what? Because this is end of life since for a decade almost. No, not really, but it feels like that. So this is what you get if you run podman run CentOS 7 and you yum install Python. Then it will actually, it will just not work because it cannot retrieve the packages, the mirror list. I mean, this is a deliberate choice. They are like, this is all insecure crap, you should not use this. So you can use it, you just need to change, this mirror list here to some other domain and then it works. But they actually don't give you the instructions to do that. You need to go basically on Stack Overflow to figure this out. And it's not hard, but it's like, yeah, you have your container file and it still doesn't work. So I got a bit frustrated with that. And also I'm now in astronomy working with ESO, with the telescopes, and they are like, their unofficial plan is that their data should be reprocessable for 100 years. They cannot make an official commitment to that, but that's what they want. That basically if somebody in 100 years time are like, I want to reprocess this data, they can just do it with the software. And then that's basically an unattainable goal. Well, it's not, we need to do something better than we did so far. I'm not saying Guix is the solution, but it's a good path into that direction. Because, for example, for the availability of libraries, for example, this is in my practice, I always do an apt-get update in my Docker container files, and then it always, it's just not good. So what Guix does, so you saw these hashes. Let me show you them again. So these directory names all start with this is not a directory, whatever. They all start with a hash, and this is sort of a hash of the input, basically. So you don't even need to build the packets to compute this hash. I'm not sure whether that's the difference with Nix, but I thought so. And they're all built offline in a container without internet. So you cannot secretly, and also also in a build container, it doesn't have anything. Like if you call grep in your build script, you need to have specified grep as a dependency because otherwise it's not there. And so some of these packages to add them, it's like kind of a whack-a-mole. Because you notice that these build scripts or the programs themselves actually use things they assume will be there. And they partner with the Software Heritage Foundation. That was really, they basically try to put any software in their archive and in a smart way. It's actually a French project. It's also nice, so it's not all on American servers. I suppose they also have American servers. I don't know. And of course, you never know whether this actually stays, but it does help. So I installed WCS lib a couple of weeks ago, and it turned out to be this was hosted on a university website, but then university decided, personal websites must go. It's a security risk, so software was gone. And then actually, that was actually on the Internet Archive, I think. So if you try to install a package through Guix, and it cannot find the source it should be located in, then it will actually just look anywhere else, basically here on this software heritage, but also on the Internet Archive until it finds what it wants. And that is sort of fine, because if you recall this package definition, there's this hash. Well, it's just a hash of this tarball. Oh, this is another package, whatever, it doesn't matter. Basically, there's no risk in downloading it from some weird thing website whatsoever. 5 minutes, okay, good. So let's show me a bit like, so I was like, good, this is great. And then I used Guix, and it has Python 3.11, and I was like, this doesn't fly because all our software we just upgraded to 3.12. So actually my own software doesn't work on Guix. Like, crap. So I will highlight some of these problems with this upgrade. So I was like, there is open source. I wrote this. Well, most of this was actually done by these two guys. I don't know whether they're guys actually. I met Charlotte and Helse here, but not Nicolas. Let me show you. So this is the Git log from the Python team branch. So I want to take you 2 things away from this. It's basically, you need these 2 people, and then I'm apparently number 3. I didn't know that, but only 41 commits. But you see that this is from the upgrading the Python branch. So this is like more than 500 commits beyond just upgrading Python. Because the normal update just looks like this, right? Package update, you just change the version number and the hash, then you're done. But this doesn't work with Python because Python is so embedded, like there are 30,000 packages in Guix, but 6,000 of them depend on Python. So if you update Python, 6,000 packages might break, but apparently it's about 500 that break. So about 10% of the packages break if you just upgrade Python. And I think this is surprising. This shouldn't be the case, right? But even from 3.11.11 to 3.11.14 broke some things. And this is the only way I could plot the dependency graph of all the 6,000 dependencies. And it takes ages because even Rust has some test scripts or something that use Python. And Rust, you require Rust to build Rust. So if you need the latest Rust, you need to build all the other Rust. So you basically, if you change something in Python, your computer is spending 3 hours or 3 days compiling Rust. But yeah, for example, one thing you can do is graphs. That's nice. So you just basically say in the Python package, well, don't use this replacement one. And that is actually the 3.11.14. Yeah, but then you hide basically the failures. And you also have inheritance. So the inheritance was wrong because Python 3.11 inherited from Python 3.10. You could see this in this previous slide, I think. Like this fixed version inherited from the previous one. But this went all the way back to Python 2.7. So we could never get rid of Python 2.7. So the inheritance should be the other way around. Just to change that. And also, like, what is now part of Python? Like, is pip part of Python? Well, now it is, since 3.5, but actually Guix replaces actually pip in this sense, so you don't need it, so you need to remove it. And there's quite some software that depends on distutils, but that doesn't exist anymore. It's now part of setup tools. And then so there are many, and then you need setup tools. And now there are many of these commits where you just add Python setup tools because suddenly Python decided that it's work that you need to explicitly do this. Well, it's fine. Oh, and it's what you also see in this figure here that all these build systems are reported. I think here it's heads. Oh, I thought so. Oh, I don't know. And also you see here the change, like many of these commits like change the source from PyPy to actually to the Git reference because, well, in the off chance that there's this exact attack, you know, there's like, yeah, you don't know whether this build package is good. And testing is also annoying because there's no, in Python there's no, you can, like in these GNU systems, you can just do make check and whatever it does its thing. That is not really in Python things. And then you have all these different these backends, and then suddenly nose doesn't exist anymore, then you need to, I mean, those are the small problems to solve. And there are some circular dependencies are always nice, because if you want bootstrapability, basically the idea is also Debian is also in this effort, and Nix as well. Basically, you just write, 200 characters in hex, and the rest, you build your entire system from that. Let me show one of these. So for example, HTTPX depends on HTTPX. To test the Python HTTPX, you need to have HTTPX already available. So basically, it's our interesting. I think this is an interesting puzzle to make these packages. Well, this is actually, well, I have more slides, but this is my last one. So I think you can try Guix for fun and profit. I think it can work very well in place where you want reproducibility. And I especially use it for Python because some of these problems are worse in Python than, for example, in Rust. Rust code will always compile, I think, but Python code doesn't always run. And I would invite you to add your own packages. Well, that was what I wanted to say.